Now let us see the condition for parallel lines. We have seen the formula for angle between two lines, so that is cos theta as given here in terms of the direction cosines as well as in terms of the direction ratios of the two lines. Now suppose we want to develop a condition to test whether the two lines are parallel or not, depending on by knowing the values of their direction cosines or direction ratios. Then now you see that if the two lines are parallel, then clearly the angle between them, we have to take it at 0 degrees. So by that, cos of 0 turns out to be 1. So that means we want this particular ratio, or rather this particular expression, to be equal to 1. Alright. So for that, what we must have is, if you consider L1, M1 and N1, and if you consider L2, M2 and N2, then these ratios must be exactly same or negative of each other. Because what will happen is, if it is not the case, then the value of this particular expression would become bigger than 1 also. So therefore let us consider what happens if we take L1 upon L2 to be equal to 1. So in that case, L1 and L2 both can be taken as, say, L, because both the values are same. So since both are same, we get L square. Similarly, for the second one, we can take both the values as m, so that is m square and n square, correct? And we know that this is equal to already 1. So therefore this is the condition in direction cosines for the two lines to be parallel. Now suppose we want to develop the condition for parallel lines considering their direction ratios, that is a, b and c. Now here, since they are ratios, there is no restriction, or there is no mandate that that common ratio has to be equal to plus or minus 1 only, but it can be any common ratio. So therefore here we just say that a1 upon a2 should be equal to b1 upon b2, and that in turn should be equal to c1 upon c2. That's it. So that is the requirement for condition to be parallel lines. Now let us go ahead and see the condition for perpendicular lines. Now once again we have written the formulae for cos theta for condition of perpendicular lines. Now since for perpendicular lines we want theta to be 90, hence cos of 90 turns out to be 0. So that means we want this entire expression to be equal to 0. Now here it is little simpler, because we can directly say that L1 plus L2, sorry, L1 L2 plus M1 M2 plus N1 N2 itself has to be equal to 0, because only then the required expression would be 0. And on the other hand, we also must have, in the second equation, we must have the numerator to be equal to 0, because we want the entire expression to be equal to 0. Alright, so therefore in case of direction ratios, the condition turns out to be a1 a2 plus b1 b2 plus c1 c2 to be equal to 0. Alright, so these are the conditions for the two lines to be perpendicular to each other.